Welcome students. So in today's video we are going to discuss the empirical formula, the calculation of empirical formula. Okay, empirical formula. As in the last class we were discussing about this thing only. Okay, so let's have a brief description about this and solve some of the questions for clarifying this particular topic. So for this particular empirical formula, how to solve the question. Okay, so for that let's take an example only, and on the basis of that example only I am going to explain you how to solve this type of question. So a question is asking here, the molecular mass of an organic compound is 78 and its percentage composition is 92.4% of carbon and 7.6% of hydrogen. Determine the molecular formula of the compound. Okay, we have determined here the molecular formula of the compound. Okay, so solution. So as discussed in the class also, that we have to form a table here. So let's form a table here. For solving empirical formula, you can easily solve by making this table. Okay, and this method is more reliable as comparison to other method because it makes out the least error. Okay, it creates the least error. So this is the table which we are going to use here. Okay, now total six we are taking here, six columns: 1, 2, 3, 4, 5 and 6. These are the 6 columns which we are going to use here. Okay, so let's start. The first column is for the elements. The second column is for the percentage of elements which is present in your compound. Okay, so third one is for the atomic mass of each elements. Okay, then moles of atoms of elements which is present in your compound. Then mole ratio or simplest mole ratio. Okay, you can term it as simplest ratio, simplest molar ratio, any other name you can take. Okay, and the last one is the simplest whole number ratio, simplest whole number ratio. Okay, it is like this. Now let's start the question, solving it. So two elements are given here, one is carbon and the other one is hydrogen. Two elements are given here, and for these two elements only we have to form out the we have to form out what we have to form out here, the empirical formula. So here the percentage of carbon in the question, it is given 92.4%, and for hydrogen it is given 7.6%. Okay, the atomic mass for carbon is 12 and for hydrogen it is 1. So for finding out the moles, divide the given percentage by the atomic mass of the element. Divide the given percentage of the element by the atomic mass of the element. So on dividing 92.4 by 12, we will get here 7.7. Okay, and on dividing 7.6 by 1, we will get here 7.6. Now, out of these two values of moles, 7.6 is the least value. Okay, so divide this 7.6 to 7.6 from both these numbers, both these moles. So 7.7 divided by 7.6, 7.6 divided by 7.6. So here 1 will be there, and here 0 point, sorry, 1.01 will be there. 1.01 will be there. 1.01 will be there. Okay. So now we have to convert these numbers to the nearest whole number. So the nearest whole number for 1.01 will be 1, and 1 is whole number in itself, so therefore no need to convert itself. So the empirical formula becomes out here. So the empirical formula becomes out here. CH is the empirical formula. Empirical formula. Okay, because here the ratio has came out to be 1 is to 1 na? So here the ratio, see what I have given the definition in the class for empirical formula. It gives the simplest ratio. It gives the simplest ratio for the number of compounds, for the number of compounds present, for the number of atoms of the elements present in a compound. Okay, so here it means it is showing that one atom of carbon is been attached with one atom of hydrogen to form this particular compound. Now we have to convert this empirical formula into molecular formula. So the relationship between the empirical formula and molecular formula was that we have to find out the n here. Okay, n here. So the n value was can be found out by molecular mass divided by empirical formula mass. So the molecular mass here, if I am taking out the molecular mass, then it will become 12 plus 1, molecular mass of the compound. Okay, here it will be the molecular mass of the compound, and the compound is found out here is CH. So here the value will become 12 plus 1 divided by empirical formula mass. Okay, so sorry. The molecular mass is given in the question, I think so. It is 78. The molecular mass is given in the question. It is 78. It is given in the question, and empirical formula mass is taken out to be 12 plus 1 13. Empirical formula is CH and 1 and 1. So one carbon is having 12 mass, and one hydrogen is having 1 mass. So 1 plus 12 is equals to 30. Now dividing 78 by 13. So the answer will come out here to be 6. Okay, the answer will come out to be 6. So the relationship between the empirical formula and the molecular formula was empirical formula is equals to n into molecular formula. Sorry, the relation was molecular formula is equals to n into empirical formula. Molecular formula is equals to n into empirical formula. Okay, molecular formula is equals to n into empirical formula. So here the molecular formula will become molecular formula for the required compound will become here 6 into CH. Okay, 6 into CH. So it will become C6H6. Okay, C6H6. Now let's take another example and solve it. So the question is asking here, an organic compound on analysis Give the following percentage composition. Carbon is equals to 57.8%, hydrogen is equals to 3.6%, and the rest is oxygen. And the rest is oxygen. Also, the vapor density, the vapor density of compound was found to be 83. Find out the molecular formula. Find out the molecular formula. Solution. Okay. So here also we have to make out a table. Okay. So let's make out the table. Second for the percentage, first for the element, second for the percentage, third for the moles. Sorry, third for the atomic mass, fourth for the moles, then fifth for your simplest ratio, and sixth for your simplest whole number ratio. Okay, so you have to remember this six columns, and according to this only you have to make out the table here. Now let's start. For elements, first is for elements, second is for percentage, third is for atomic mass, moles of atoms, simplest ratio molar. Okay, simplest molar ratio or mole ratio, you can call it as mole ratio also. And the last one is the simplest whole number ratio. Simplest whole number ratio. Okay, so let's start to solve this question here. Three elements are there here: carbon, oxygen, and hydrogen. Okay, carbon, oxygen, and hydrogen is present here. The percentage of carbon is 57.8 and the percentage of hydrogen is 3.6. Adding these two, we will get 57.8 plus 3.6. 14, 1, 11, 1, 61.4. Now, subtracting this from 100, we will get 6, 9, 8, and 9, 3. 38.6 will be the percentage of your oxygen. Okay, what I have done, I have first added the percentage for hydrogen and carbon which is provided to me, then subtracted it from the 100%. Okay, 100%. So I have got the value for the percentage of oxygen. It is 38.6. Now atomic mass for carbon it is 12, for oxygen it is 16, and for hydrogen it is 1. So the moles of the compound, the moles of the elements will become 57.8 divided by 12. Okay, 57.8 divided by 12. Four times I will, if do, then point I will put 8 times. 90 will be there 8 times, then 2 times. Okay, next 38.6 divided by 16. So 2 times, sorry, not 2 times, then 4 times and 1 time. Last 3.6 divided by 1, so it will become 3.6 only. Okay, now we have to find out the simplest ratio. So first to find out the smallest number, so the smallest number is 2.41. So 4.82 divided by 2.41. Similarly, 2.41 divided by 2.41, and last is 3.6 divided by 2.41. So the values will be 4.82 divided by 2.41, it will be 2. Okay, 2.41 divided by 2.41, it will be 1. And here 3.6 divided by 2.41, 1 times, if I will cancel it out, then 4 times it will be there, then 9 times it will be there. Okay, so here we can see that 1.5, 1 and 2 is there. 1.5, 1 and 2 is there. So a decimal is out there, a decimal is there. So I can convert this decimal into a whole number by multiplying it with 2. But if I am multiplying it with 2, then I have to multiply all other with 2. Okay, so then the simplest whole number ratio will become 4, 2 and 3. Okay, how I have done here, how I have chosen what to multiply. I have taken the decimal number here, the decimal number which is present out here, and on the basis of that decimal number, how to convert this decimal into whole number. So for that I can multiply it with 2 na. So if I am multiplying this particular value with 2, then all the others will also be multiplied with 2 only. So the answer will become 423. Now, the empirical formula will become here. The empirical formula, after the calculation of this here, it will become empirical formula is equals to C4O2H3. Okay, C4O2H3. Or if you want to write in series na, because this is a organic compound, so write H with C only, so it will become C4H3O2. C4H3O2. This will be the formula, empirical formula. Now we have to find out the molecular formula. So for molecular formula, we have to find out the value of N. N is equals to molecular mass. Okay, so here molecular mass is not given. Formula is molecular mass divided by empirical formulas molecular mass. Empirical molecular mass. Okay, empirical formulas molecular mass. So here we have to first find out, because in the question density is given, vapor density. Okay, so we have to find out the molecular mass. So molecular mass here, it will become the 2 times of the vapor density. Okay, it will become the 2 times of the vapor density. Okay, multiply the formula with the, okay, so 2 times of the vapor density. So it will become 2 into 83, so 126, 166, 6 or 118, 16, 166. Okay, so empirical formulas molecular mass will be there. Empirical formula molecular mass is equals to, it is 4 into 12 plus 3 into 16 plus 2 into 1. No, I think so I am wrong. 3 into 1 plus 2 into 16. Okay, this will be there. 4 into 12 plus 3 into 1 plus 2 into 16. So here it will become 20, 48 plus 13, 3 plus 48 plus 3 plus 32. So 35 plus 48, 35 plus 48, 13, 448, 83. Okay, 83 will be the empirical formula. Now put it in the formula, 166 divided by 83. So our answer will come out to be 2. Okay, if I am cancel it, so it will be 2. So our answer for n is 2. So the molecular formula required here becomes 2 into C4H3O2. So it will become C8H6O4. C8H6O4. Okay, so this is the answer. This is the answer. This is the molecular formula which has been required out here. Okay. Now let's see the next type of question which can be asked out from empirical formula. Okay. So question here is 4 grams of copper, 4 grams of copper chloride on analysis was found to contain was found to contain 1.890 grams of copper. Okay, 1.890 grams of copper and 2.110 grams of chlorine. Okay, 2.110 grams of chlorine. What is the empirical formula of copper chloride? What is the, ये तो निकालना पड़ेगा ना, CuCl2 we have to find out. So copper chloride, copper chloride. Okay, so what is the empirical formula for copper chloride solution? So first we have to find the percentage. Here you can see that it is mass is given. So we have to first find out the percentage of each of the element which is present here. Okay, so the first step is to calculate the percentage of copper in the given compound. So it will be calculated by weight of copper divided by weight of copper chloride multiplied by 100. So the weight of copper, it is given 1.890 divided by 4 into 100. Okay, so 4 0.4 4s are 16, 29, 7s are 28, 1 0, 2s are 5 into 100. So the percentage will come out to be here, percentage of copper, it will come out to be here 47.25%. Similarly, percentage of chlorine, weight of chlorine divided by weight of copper chloride into 100%. So here weight of chlorine is 2.100, 2.110 divided by 4 into 100. Okay, so 4 4s are 16. Okay, 4 4s are 16. 0.4 4s are 16. 5 1 51 51, no, sorry, 5 1s are 1 1 1 1 2s are 3 30 37s are 2s are 5, 41275. So on multiplying it with 100, we will get percentage of CL is equals to 41.275 percentage. So you can take 47.27 only. Okay, you can skip out this 5 here. Okay, so now, oh, sorry. That's my mistake. That's my mistake. So here it will be uh, fives are, yeah, fives are 20, 1, then twos are, so 10 point, it will become fives are 20, 1, 11 twos are, so 3, 30, sevens are, fives are 52.7. Okay, 52.75. Sorry, this was my mistake. So this is the percentage of chlorine. Percentage of chlorine, it is 52.75%. 52.75%. Okay. Now we have to calculate the empirical formula. For that, we have to form out the table here. So form out the table here. 3, 4, 5, and 6. Okay. So first, elements. What are the elements which is given here? Copper and chloride. Then the percentage. Percentage of element was 47.25 and 52.7. Then after percentage of element, we have to find out the atomic mass. Atomic mass for chlorine, it is 63.5, and for chlorine it is 35.5. 63.5 and 35.5. Okay, so let's move further and next calculate the mole of atoms. So mole of atom, it will become 47.25 divided by 63.5, and here 52.75 divided by 35.5. Okay, so on dividing here we will get 0.74 and 1.48. 1.48. Okay, so this will be the values for moles of atom. Now mole ratio. Okay, we have to find out the next is the mole ratio or molar ratio. Simplest molar ratio. Okay, simplest molar ratio. In different books, different denotations are there. So don't get confused out here. Okay, so here we will take the smallest number. Smallest number is 0.74 divided by both. So 0.74 divided by 0.74, 1.48 divided by 0.74. So here it will be 1, and here it will be, I think so, 2. 0.78. No, it is not 78, it is 7. 0.7. Okay, so here the value will become 2. So both the numbers are in simplest form only, so no need to multiply or change any make any change there. So the simplest whole number ratio is 1 and 2 only. So the empirical formula forms out to be CuCl2. CuCl. Okay, now let's take another question. The question here is asking a compound contains 4.07% hydrogen, 24.27% carbon, and 71.6% of oxygen. Of chlorine. 71.65%. 65. Okay, to be more precise, it is 65% of chlorine. Okay. So here we have to find out its molecular formula. Its molecular mass is given. It is given its molecular mass is 98.96. Find the molecular and empirical formula. What is the empirical and molecular formula? Two, 3, 4, 5 and 6. Okay, now let's start. Elements. So the elements here are 3 elements: hydrogen, carbon and chlorine. So carbon, hydrogen, chlorine. Percentage of elements. Percentage for carbon 24.27, for hydrogen 4.07, and for chlorine it is 71.65. Then atomic mass for each element: carbon it is 12, hydrogen it is 1, and for chlorine it is 35.5. Now calculating the mole of atoms present in the compound. So for that, divide percentage by the atomic mass. Percentage by the atomic mass, and here 71.65, 35.5. Okay, so here it will become 2 times point 0, 2.02. Okay, here it will become 2.02. Here 4.07 only, and here 2 times, then 0.160, 165. 165 means then again 0. Okay, so the smallest number here is 2.02. So the simplest molar ratio or mole ratio, okay, simplest molar ratio or mole ratio comes out to be 2.02 divided by 2.02, 4.07 divided by 2.02, 2.02 divided by 2.01. Here it will come, I think so, 2. It will come 2, near about 2. Okay, near about 2, 1 point something, you can take it to 1, and here it also 1. So no need to convert here, no need to convert them into more simplest form. They are in their simplest whole number form. Okay, simplest whole number ratio, so no need to convert it into, so it will be like this only, 1 to 1. Okay, so the empirical formula will become here, empirical formula will become here CH2Cl. CH2Cl. This is the empirical formula. Now let's start the calculation for the molecular formula. For molecular formula, we have to find out the value of N. So the N is equals to molecular mass, which is given 98.96, divided by 12 plus 2 plus 35.5. So the value will become 98.96 divided by 14 plus 35.5, it will become 49.5. Okay, so on dividing it, 49.5, and yeah, so it will come about, I think so, 2. It will come about to the whole number near to 2. Okay, so our answer becomes 2. So here the molecular formula is molecular formula is equals to 2 into 2 into CH2Cl, so it will become C2H4Cl2, C2H4Cl2. So this is our answer. This is the required answer for the question. At last, let's discuss a very important question. Okay, a compound on analysis, a compound on analysis gave the following, percentage composition, percentage composition. Na, sodium 14.31%, sulfur 9.97%, hydrogen 6.22%, and oxygen 69.5%. Okay, and it is asking to calculate the molecular formula of compound on the assumption that all the hydrogen atoms in the compound are combined with oxygen to form water of crystallization, Okay, the molecular mass of the compound, the molecular mass of compound is 322, and sodium's atomic mass 23, it is given, sulfur's atomic mass 32, it is given, hydrogen's atomic mass 1 is given, and oxygen's atomic mass 16 is given. So we have to solve this question. So first we found out the table element. So for element it is given as sodium, then sulfur, then hydrogen, and then oxygen. Next, percentage. So percentage of element, is 14.31, 9.97, 6.22, 69.5. Okay. Then atomic mass. Atomic mass. For sodium it is given 23. For sulfur it is given 32. For hydrogen it is given 1. And for oxygen it is given 16. After this, mole of elements or mole of atoms in the compound. So here it will become 14.31 divided by 23, 9.97 divided by 32, 6.21 divided by 1, 69.5 divided by. So 14.31 divided by 23. It becomes 0 times I will make it. So 143. 143, 6 times it will be. Okay. So 6 times 6 threes are 18, 12, 13, 138. 138, 5, 51. 51 means 2 times I will take. So 62. Next here also point 0.99. 32 threes are 6, 96. Okay, threes are 96, 3, 37. 37 I think so 1 time. Okay, so 0.31. Here 6.22 and here 69.5. 69.50 divided by 16. Oh, sorry. 69.50 divided by 16. So it will become 16 fours are 16 fours are 64. 5.55. 55 means 3 times 40. 4.3. Then 48 to 45, 70. 17 then again goes for 4 times 60. Okay, so 3.4. Next, simplest whole number ratio. For simplest whole number ratio, we have to find out the smallest number. Smallest number is 0.31. So dividing all of the values from 0.31, here it will get simplest ratio or mole ratio. So here we will get 0.62 divided by 0.31. 0.31 0.31 divided by 0.31 is equals to 1. Okay, 6.22 divided by 0.3, it will become 20. Okay, 2s are 0, 20. And for oxygen, 4.34 divided by 0.31, it will come 14. Okay, so here all the numbers are in whole number form, so no need to change anything. 2, 1, 20, 14. This will be the answer. Okay, let's now find out the empirical formula. Empirical formula, it will become Na2S Na2S1 S1 H20O40 H20O. Okay, so let's find out the molecular formula. So for molecular formula, N will be required, and the molecular mass is given here in the question as 322. 322 divided by 2 into 23 plus 632. Okay, because one hydrogen, one sulfur is there, so only 32 will be multiplied out there, plus 20 plus 14 into 16. 14 into 16. So here on multiplying and adding 46 plus 32 plus 20 plus 14 into 16, 4, 2, 6, 8, 84, 4, 1, 224. Okay, so 224 plus 20, 244, 244 plus 244 plus 30, 274, 274 plus 46, 10, 320. Okay, it will become 322 only. It will become 322 only. 46 is there, here also 46, so it will become 46. So 224, 224 plus 20, 244 plus 32, 276. Okay, 276 it is. 6, 6, 12, 11, 12, 320. So 322. So the n value is 1. Value of n is 1 here. Okay. So the molecular formula will become molecular formula is equals to NaSO4. Okay, Na2SO4 and 20 hydrogens will collaborate with 10 oxygens. Okay, so it will form 10H2. So this is our compound, because in the question it has asked that we have to find out the water of crystallization there. So the water's formula is H2O, 2:1 ratio. Okay, so if 20 hydrogens are there, then how many oxygens will be required? 10 oxygens will be required out. So the left 4 oxygens will be taken from the taken with the given compound. Okay, so the given compound becomes Na2SO4.10H2. Okay, so students, this was for our empirical formula, and with this particular topic we have completed the chapter. Okay, we have completed the chapter. I think so. No more thing is being left out there. If anything will be left out, we will discuss it in the class. Okay, we will discuss it in the class. Okay, I think so. Stoichiometric calculation has been left out. So we will discuss that stoichiometric relation in our class. Okay, we will discuss that stoichiometric relation in our class. So for this particular session, I am ending here only. We will meet in our next session. Thank you.